Hello students, today we will continue learning about work and energy. I am wearing the mask, it will be disturbing, so let me remove it. Now, in this chapter, we already said that work done is equal to force multiplied by displacement. And also we derived an equation for kinetic energy. Kinetic energy we represent as energy kinetic EK is equal to half mv square, where m is the mass and v is the velocity with which the body is hitting the object. Fine, it can be a bullet, it can be a stone, it can be a ball, anything it can be. Now, today we will learn the another type of energy, that is potential energy. Right. Now we are going to discuss about potential energy. Now, potential energy is energy due to its position. The object's position that decides the energy possessed by the body. Now, how is that going to be? For example, let me take this chalk box. Fine. Now, the chalk box is, let us say, from reference to the ground. With reference to the ground, the chalk box is in this position. Right. And the chalk box is having a mass m. And you know that a body with a mass m will be attracted towards the ground with the acceleration due to gravity. On the earth it is going to be g is 9.8 meter per second square or 10 meter per second square. So the weight of the body is acting downward. Now I take this box and I lift it up. While lifting up, I do work, right? And the body is come from here and it is reached this point here. Now it is traveled a height h. The distance traveled or displacement is h of the body, and mg is acting downwards. Now what is the energy possessed? Now due to its position, it is possessing energy. When I take this body and lift it up here, I have done work. Now you know that work done is equal to force into displacement. Now, what is the force now? I am applying, I am making the body, which is having a weight. I am lifting this body. So, I am lifting the weight. So, this F is nothing but m into g. You know Newton's second law, F is equal to m into a. This a is acceleration in the horizontal way. The same force will modify as F is equal to mg when the body is falling or moving up with the g. That is vertical motion. This is horizontal motion and this is vertical motion. Now what is acting downward? Weight of the body. So mg is weight of the body, the force. First let us define weight. Weight is gravitational force acting on a body. It is the gravitational force. So force is F, which is mg multiplied by what is the displacement of the body, which is h. So I put it h. So work done is equal to mgh is the formula. Now that is the amount of work I have done to shift the body from the ground, this is the reference point, to a particular height h. Now this work is stored as potential energy. Potential energy is due to position, so mgh. So we can simply write energy EP is equal to mgh, and this is the formula for potential energy. I hope you understand. Everything again we come back from the same point, that work done is force into displacement. Force is weight of the body acting downward direction. S is the displacement where it is vertical height. So mg into h and gives you potential energy. Now we need to study a bit extra about it. See, suppose someone takes the body from here and moves it like this and brings the body to this position. Fine. The same body, it is coming to this position, and again he takes it back and he brings it like this. Fine. And he brings it up here. He moves it like this and again he moves it back like this and again he is lifting it up like this. What will be the potential energy, or what will be the work done? Remember, work done is force into displacement. Displacement is the shortest distance covered. Our displacement is the distance between the initial and final position. We don't worry whether the body has been taken in this way, this way, this way, this way. It doesn't matter. The force does not depend on the path. It does not depend on the path traveled by the body. So you'll find that it only depends on the actual displacement of the body, which is h here. It does not depend on the path. Such a force, such a field is called conservative field. It is referred as conservative field or conservative force, you can say, where it does not depend on the path of the body. Now what I am going to do, I have taken again our basis 9th standard. Keeping 9th standard as a reference, we shall do 1 or 2 numericals, then it will be better for you. Yeah, you will understand the concept much better. Okay, let this derivation be in this side. Now, in your textbook of 9th standard, science 11.5, the question is like this: energy possessed by a body is how much? Energy possessed by the body is how much? Question mark. When the mass of the body m is equal to 10 kilogram, that is the SI unit, and height of the body h is equal to 6 meter, and g is equal to 9.8 meter per second square, but I always approximate equal to 10 meter per second square, because for me the concept is more important than the calculation. Calculation is something more to do with mathematical thinking. So concept you should learn in physics. Right. Now when I keep this point like this and I know the formula that whenever height is involved, it is potential energy. So this is potential energy. So EP is equal to mgh, which is equal to, what is the mass? 10. And what is the g, acceleration due to gravity? 10. And what is the height traveled? 6, which is 100 into 6, 600. What is the unit of energy? Any type of energy, it is joule. So this is the potential energy of the body. Okay, I think your book might have given something like 588 joules. So don't worry about it. That is up to you and your teacher who is dealing with the class. You can consult with the teacher. Let me do one more numerical. Yeah, I say that numerical will make you much comfortable in understanding the concept. Now, this is question number 11.6. In this, they have given mass is 12 kilogram and height you have to calculate, and they have given energy as 480 joule and G is same. In your textbook, maybe in some textbooks there is an error. G is given as 120. Don't worry, it is not 120. That is only 10 meter per second squared, which you can check it in your answer. Let us do the problem now. This energy is 480, that is equal to mass is 12 into G is 10 into height is h. Yes, I do it in a simple way. I cancel this 0 and this 0. So I got H is equal to 48 divided by 12. That is, it will go, I think, 4 times, yeah. So therefore, H is equal to 4 meter. You can see the textbook answer. The answer is 4 meter. So by this way, you can understand the concept of potential energy. So I hope you understand the concept of potential energy, and also we said previously kinetic energy or EK is equal to half mv square. Okay, so they are all interrelated. Together, the kinetic energy of the body and potential energy of the body, together the total energy, this is called mechanical energy, or the total energy can be, the mechanical energy can be either potential energy or kinetic energy, and the total energy will give you the value of it. Now I am going to do the final point of it, comparing potential energy and kinetic energy. Are they one and the same? If I say energies are same, I say mechanical energy is same, will it be same or not? That we can find out. For example, I take a body, let us say I take a ball and I lift the ball to a height, let us say I lift the ball to a height h. Fine, let us take the point from here, from the ground, and this is the height traveled by the body. Okay, let us say this is the ground position A and this is the highest position B. Watch very carefully, it's a next discussion we are doing, right? And I have taken this chalk piece as the ball. Now what is going to happen? We know that the mass of the body is m, and what is the initial velocity of the body? U is some value, right? And it goes here and its value becomes v, and at the highest point the velocity is going to be equal to 0, and the body will fall down like this. The body will fall down like this, because you see carefully, the body is here and I throw the body up, and momentarily the body comes to rest and then it falls down. So what will be the velocity at the highest point? The velocity will be 0. Now let us see what is the total energy possessed by the body at this point B. That will be kinetic energy plus potential energy. When velocity is 0, that is nothing but half mv square plus mgh, right? V has become 0, so total energy at the point B is mgh. Keep this in mind. This is one part of it. At this point, the energy is mgh. Now, this point A, it is going to come back and strike it here. When it comes back and strikes it, it is having a value, and some velocity value it is going to have. Let us interchange it. When it comes down, the initial velocity is 0 here, and it's coming here and it's striking with the velocity v. Now, but what is the height when it comes here? The height is equal to 0. Watch carefully. The body is now being dropped from up to down. When I take it here, its velocity is 0. So that is why I have put half mv square. This velocity can be final or initial. So this velocity is 0. So half mv square is gone. There is no kinetic energy, only potential energy. Now I discuss it further. Total energy at A is equal to kinetic energy plus potential energy. So what is the kinetic energy? Half mv square plus, what is the potential energy? mgh. But height is 0, so therefore here the potential energy becomes 0. So total energy at A is equal to half mv square. Now watch carefully here. This is half mv square. Is total energy at B is equal to total energy at A? Yes, we can prove it now very easily. It just requires a little bit of changing of the points from one to the another. If I prove that, I am going to prove something much bigger, right? I know that total energy at A is equal to half mv square. Take the third equation of motion. For vertical motion, v square minus u square is equal to 2gh. We know that body is falling down and the initial velocity has turned to be 0. So v square is equal to 2gh. Take this value and substitute it here, right? So total energy is equal to, at A is equal to half into m into 2gh. So 2 gets cancelled. So what do you get? mgh. So total energy is at the point here is mgh, and total energy. So you see at B and A the energy is same. This leads to a very important final decision, final what you will say, a law we can say, right? And that law is called law of conservation of energy. Now what is law of? From work and energy concept we are deriving law of conservation of energy. What this law says actually? It says that energy can neither be created nor destroyed. Energy can neither be created nor destroyed. So what is it? That means it can be transformed from one form to another form. For example, when I switch on the light, the electrical energy is coming and becoming light energy. When I switch on the light, when the fan is rotating, the electrical energy is converted into mechanical energy. So on and so forth. You can find so many transformations. You might have studied in small junior classes also. And here we are talking about mechanical energy, and we said kinetic energy, and another form is potential energy. When the body is here, the body is possessing potential energy and the value is mgh. And when I drop it, it comes and strikes it. If I keep a piece of chalk piece, the chalk piece will go into smithereens. It will break into pieces, right? But what is the energy that time? That is kinetic energy. But kinetic energy half mv square. By taking the third equation of motion, we can say that the kinetic energy value is same, mgh. If the body had 100 joule energy, when it falls down, it will have same 100 joule energy. So this is what the law of conservation of energy is about. Energy is neither created nor destroyed. It can change from one form to another. And here it is from potential energy, it is changing into kinetic energy. It is one of the simple illustration to prove law of conservation of energy. I hope you understand this concept. Try to learn and relearn. You will understand much better. Thank you so much.